All right, so in this video, I'm going to be explaining to you what free body diagrams are and how to solve the problems on your assignment using free body diagrams. So to begin with, the free body diagram is just a representation of forces on an object or multiple objects. So for example, we usually draw them in the shape of a square. Let me get a square. And let's say that this square is going to represent me. Maybe I got to move my couch from where it is so I can sweep under it and move it somewhere else. And so I'm going to push on one side of the couch and apply a force to it. And so to represent that force, I'm going to draw an arrow on one side of the couch. So in this case, I'd be pushing the couch from left to right. And then I'm going to say how much force that took. And I'll say maybe I pushed with the force of 30 newtons of force. And that would basically be it. That's the free body diagram. It shows that I pushed the couch with some amount of force from the left to the right. Now, there are other forces that we need to add into this diagram as well, though. Usually on your problems, I'll tell you which ones you do or don't need to consider. But one that you always have to think about is the force of gravity. Gravity is this force that's always pulling things down. So I'm going to draw an arrow on it like so. And I can label that force of gravity. I'm not going to put a number on that. It's not important for this problem how much that force is. But another force that's important to bring up is friction. Friction is a force that resists changes in motion. And so if I'm pushing with a force to the right, friction is going to push with a smaller force because I'm still able to move the couch, but with a smaller force to the left, to the opposite direction of what I'm pushing. And I'll just call that force friction. And this would be a pretty complete free body diagram then. Some other forces that you might want to think about when you're doing these, if an object is falling through the sky, maybe a baseball is falling down from the sky or an acorn is falling out of a tree, gravity would still be there. But this time, let's say there's no forces pushing it left or right. So let me get rid of those. If this is now an acorn falling out of a tree, gravity is pulling it down. There's also going to be friction pushing up on it. Let me spin my arrow, maybe. Got the wrong kind. There we go. The friction is pushing back against that gravity, but in this case, since it's going through air, we would call that the force of air resistance. Same as friction, it's just friction through the air. And then one final force that's worth noting about, because this occurs in a lot of your problems, is a force that's applied to an object when it's resting on a surface. So let's say I have a table. Oops, wrong one. Let's say I have a table, and on that table is a book. And I want to know the forces happening to that book while it's just sitting there. Well, any object that's on Earth is going to have gravity pulling it down. And so this is my force of gravity pulling downward on that book. Oops, don't need that extra arrow. Now the book just sits on the table, though. It's not going through the table, and that's because the table is pushing against that book. So whenever an object is resting on another object, like a book on a table, like a car on the road, anything like that, there's a force that resists gravity, and it equally resists it. It's the exact same amount of force because that book's not moving. It's not going down. And that force is called the normal force. And so I'd label this one force normal. A lot of the problems on your paper are gonna have that force in it. A lot of the problems are gonna require you to put gravity or normal force, and then some of them won't. And usually, if they don't, I will mention that in the problem. I might say something like ignore friction or ignore gravity, something like that. Now, some of the problems require you to solve for the net force. The net force is the total force on an object. So if I look at some of your problems from your paper at the beginning, these are the first problem. It says free body diagrams and force situations are shown below. For each situation, determine the net force acting on an object. So like I said, the net force is just the total amount of force on an object. And so if I look at situation A here, I can see that it has a force of 5 newtons pulling it to the left, a force of 5 newtons pushing it to the right, a force of 3 newtons pulling it up, and a force of 3 newtons pulling it down. Now, to simplify these, think about the left and right first. The left and right interact with each other in opposite ways. They don't interact with the up and down. And the up and down are opposite each other, and they don't interact with the left and right. So in this case, I have 5 newtons to the left and 5 newtons to the right. So 5 minus 5 is going to be 0. And then I have 3 newtons up, 3 newtons down. 3 minus 3 is going to be 0. So the net force on this one is equal to 0 newtons. So make sure you put the N for newtons in your answer. If I look at situation B, I can see immediately that the up and down are both 3 newtons, so those are going to cancel out. But now I have these 5 newtons of friction to the left and nothing on the right to cancel that out, which means that because that's all there is to it and there's nothing canceling it out, the net force on this box in situation B is just going to be 5 newtons. Now, there's one more important thing you got to have here, and that is a direction. Force is what's known as a vector, which means it has a unit or a size, and it has a direction. So the size of this force is 5 newtons. The direction, in this case, is going to be left. So I would just put a little arrow, say left. Or you could write the word left if you want. If I go to situation C, you can see right away the 220s are going to cancel out. You're going to end up with a net force of 0. So I can just re-put that down here. There's no direction to it. It's not moving in any way. And then for situation D, I can see I have forces up and down, but they're not equal. I have 40 newtons up and 25 newtons down. So you could use a calculator for this if you need to, but 40 minus 25 is 15. So I know my answer to situation D is going to be that my net force equals 15 newtons. But I got to make sure I put that direction. So let me grab an arrow. 15 newtons up. And that's it. That's how you do all of these different types of problems. You should work on this today. You have time in class to work on it on Wednesday too. So if you have questions or some that you couldn't figure out, I'll be here on Wednesday to help you answer those questions. And that should be about it.